Okay. So kind of as an introduction here, we've got a coordinate plane with the graph of two equations on it. The orangish red is y equals x minus 1. And the blue line is y equals negative 2x plus 4. So remember, like if they didn't have these graphs for us, this negative 1 is our y-intercept. So we know it crosses the y-axis right here at negative 1. The imaginary 1 in front of the x tells us our slope is 1, so we go up 1 over 1. This one, it crosses the y-axis at a positive 4, and the slope of negative 2 says we go down 2 over 1. Okay. So for A, it says choose some points above and below the line, y equals x minus 1. Which of them are solutions to y is greater than x minus 1, and which are solutions to y is less than x minus 1? Okay, so somebody shout out a random ordered pair. 2, 4. Okay, so the ordered pair 2, 4 is right there. It's a little off. Okay, so the point's there. If we're looking at the reddish orangish line, is that point above? Sorry, is it greater than x minus 1 or is it less than x minus 1? If you're looking at the red line, is it above or below that line, would you say?
Above.
I would say above. Okay, so that would be greater than x minus 1. Because this line tells us everywhere that is x minus 1. So this is greater than that. Okay, how about if we're comparing it to the blue line? Would you consider it to be above or below? I would say above, too. Okay, so then it would be greater than negative 2x plus 4. Okay, somebody else give me an ordered pair. Austin. Okay, that's not an ordered pair. That's it. That's part of this equation. In ordered pairs in parentheses, like 2, 4.
Oh, 4, 8.
4, 8. Okay. So if I go to 4, 8, that one's here. Okay. See how it's going to be above again on both of them. Okay, so it's greater than that. Let's pick one that's over here. We'll go negative 4, negative 1. Okay, is this purple point above or below the orangish line? Above, so it would be greater than. Is it above or below the blue line? Below. So that would be where the less than is. Okay. So the two lines divide the plane into 4 regions. Okay. This region here with the green dot is everywhere that is greater than the blue line and greater than the red line or orange line. The purple dot shows us everywhere that is greater than the red line, but less than the blue line. Now the green dot shows us everywhere that's less than the orange line and less than the blue line. And the purple dot is everywhere greater than the blue line, but less than the orange line. Okay, so those two lines can make 4 sections on the coordinate plane. And if we turn these into inequalities, we could have lots of different combinations of shades. And so that's what we're going to do today. Instead of one line that you're going to graph, you're going to have 2 or more lines that you're going to graph. So let's just look at our first example. Okay, so the solutions to a system of linear inequalities is made up of two or more linear inequalities. Solutions are ordered pairs that make all of the inequalities true. Okay, but again, because they're inequalities, there's going to be a bunch of different ordered pairs. So your answer is going to be a shaded region, not just one ordered pair. Okay, so we're going to look at each inequality separately. We have x is greater than x, or y is greater than x minus 2, and y is less than or equal to negative x plus 1. Okay, before I click on this inequality, is my line going to be solid or dashed on it? Dashed. And then is it going to be shaded above or below? Where would y be greater than? Above or below? Above. Okay, so they have the line, it's dashed, and they shade it above. They want to know where y is greater than this line. Okay, if you draw that line, y's are greater up here. Okay, for our second line, y is less than or equal to negative x plus 1. Is that line going to be solid or dashed? Solid. And are you going to shade above or below? Below. Okay, here's my line. All the y's are less than down here, so they shaded below. And then the solution is going to be where those two shadings overlap. So if they put them both together, you can see they shaded everything, but this darker area is the actual answer. Okay, that's everywhere where y is greater than the line x minus 2, but less than or equal to the line negative x plus 1. Okay, basically, you're just going to be putting two inequalities on the same graph. So very, very, very similar to the last couple of days. Okay, let's do it again. Okay, so here, this first line is the orange one. It's y is greater than or equal to negative x plus 2. So they have a solid line shaded above. And then y is less than negative x minus 2. So they have a dashed line and they shaded below. Okay, these lines are parallel. Is there anywhere that is shaded by both colors? No. So there actually isn't an answer. On these ones, you have to have double shading somewhere. It's got to overlap. Even if it's the smallest little bit, there has to be overlap. So since there is no overlap, your answer is no solution. There's no place that they overlap. There's no x and y values that you could plug into both and make them both true. Okay, because if I would look at the point 2, 1, for example, I plug in a 2 here. Okay, what's negative 2 plus 2? 0. And y is 1. Is y greater than or equal to 0? Is 1 greater than or equal to 0? Yes. Okay, if I plug in that same point here, negative 2 minus 2. Negative 2 minus 2. Negative 4, and this is still a 1. Is 1 less than negative 4? No. And that's why, like, that's not in the blue section. Like you would be able to find ordered pairs that if you replace the X and Y, you make it true. This one, you can't do it. There's no solution. Okay, so if we went back to this one, and I picked an ordered pair in this double shaded area, like even the 0.00, I plug in a 0 for Y and a 0 for X, both of those would be true. 0 is greater than -2. Is that true? 0 is greater than -2.
No.
Yeah. Yep. 0 is less than or equal to 1. Is that true? Yeah. So it is a solution. It's in that double shaded area. Okay. These will never have points that you could get both of these to be true. That's why you have no solution. Okay, so let's just try it. We've got two inequalities. Y is less than 2x and y is greater than -3. So our first one, where does it cross the y-axis? 0. Remember, it's that plus b that tells us where it crosses, and since there's nothing there, it's 0. Okay, what is my slope? 2. Okay, not the x. So we go, so we'll start here. And we'll go up 2 over 1. Okay, that is our first line. Should it be solid or dashed? Dashed. And should we shade above or below the line? I'm doing this one right here. Below. Okay, so we have that shading. Our second inequality is y is greater than -3. So I'll start by putting where -3 is on the y-axis. And then does this line show me all my -3s? Or does this line show me all the -3s? This one, okay? Yeah, close enough. Is it going to be solid or dashed?
Oh.
Which one, Austin? Dashed. And then are we going to shade above or below? Above. Okay, so this part here, that's double shaded, kind of a purpley gray color, is your solution. And again, just like on the last lesson, you don't have to like define it in any way, like that's your answer, just the graph with the shading on it. Okay, let's look at another one. Okay, here I have y is greater than or equal to -2x plus 1, and y is greater than x plus 2. Okay, if we're looking at our first one, where is it going to cross the y-axis? 1. Okay, and then what is my slope? -2, which actually that's already the right slope. Is it going to be solid or dashed? Solid. And are we going to shade above or below? Above. Okay. I can't remember exactly how yours. I guess you just do one line at a time. Yeah, they'll probably be different colors too. So like this one, I have different colored dots for the different things. My bottom one is y is greater than x plus 2. Where does this cross the y-axis? At 2. Okay, what is my slope? 1. So I go up 1, over 1. Is this line solid or dashed? Dashed. Am I shading above or below? hold on, there we go. Above. So just this little area is your answer. And you don't have to do anything extra to select it. Like the computer will know. Double shaded, that's the answer. Nope. You shouldn't have to. I don't think they'll ask. I don't think they do. If they would happen to ask, pick any point in the shaded area. Like 0, 3, or 1, 4, or 1, 5. I mean, there's tons that would work. But it has to be in that double shaded area. Okay, any questions so far? Like getting the inequalities and graphing them yourself. Okay, I mean, that's not too bad. You may also get the shaded areas and have to write the inequalities, which again is just like what we've done the last 2 days. You just have to work with one equation at a time. Okay, so let's go back to that. And we'll try this on our own. So let's look at the blue line first. Okay, where does it cross the y-axis? 4. Okay. What is the slope of the blue line?
4.
Negative 1 or negative x. So that goes down 1 over 1. Okay. Is the line solid or dashed? Solid. So I'm going to have that like equal to thing there. And then did we shade above or below? So do we want greater than or less than? Okay, that's your first line. You can forget about the blue. Okay, now on to the orangey one. Okay, where does it cross the y-axis? 3. What is the slope of that line? 2. Could be 2x. Did we shade above or below the line? Below. So is that greater than or less than? And is it solid or dashed? So we'll do it like that. That's all you have to do. Just write the inequality for both lines. You did it on the last lesson. Now you just do it twice in one problem. Okay, so we'll let them. Yeah, determine the equation of each line. Did. And then they have the 2 inequalities. So in order to get this double shaded region, you have to list both inequalities. So I think they'll ask you one at a time, probably like this line has what equation or inequality. This line has what inequality. Okay, let's see here. Go ahead and try A on your own. See if I can make it bigger. So write the 2 equations. Yep, write the 2 equalities. I'll give you like 2 minutes. Let's write them out. Like 2 minutes, and then we'll like try to together. Yeah. Okay. Well, so not y. Okay. I'll leave it in that thing here. Okay, so let's look at it. We've got the blue equation, the graph of the marker first. Where does the blue line cross the y-axis? Okay, actually, you guys messed up two ways. Technically, it's 3 by 2, so it's 2. It's 2. Okay, what is the slope of this one? Well, it goes up 2 over 2, so still 1. Okay, so it should be a positive x 1x minus 2. Okay. Did we say above or below? Okay, so is that less than or greater? Less than. Okay, let's solve it out. Okay, so you should have y is less than or equal to 1x minus 2, or just x minus 2. Okay, that's bigger. Okay. Okay, then that line, where does that cross the y-axis? Positive 2. Okay, and what's the slope for that one? Okay, yes, you're having to go down to find another point. On the line, but remember we moved from left to right. So I'm going to go from left to right. How do we know? So this is like up 2, 4, 6 over 2, 6 over 2 is 3. So that's what we're looking at. If you say above or below the line, above, nothing greater than or less than, greater than, solid it out. Okay, so this is an equality is y is less than or equal to x minus 2, and y is greater than or equal to x plus 2. Right. Try this one. Let's get closer to 2. Okay, I'm going to fix it. Yeah, we've got 2 minutes. We'll check. That's all right. I'm just down reading my book. We did, and then one guy is a day for Christmas break, we were going for it, and then another guy is free. Yeah, that's it. Sure. I am, but somebody will like do it. That's fine. Okay, go ahead. You guys can use 2 lines because let's get them through. Well, talk it through. Okay, one. Sorry. Okay, this is one line. Then red line. Okay, red orange line. Okay. The y-intercept was 0, so you don't get anything after the x. But does the line go up or down? Oh, negative. And what were the next one crosses? No, down to over 1. Oh, but it's still 2 all the way down. So no over on 1, it's still 2. Okay, so the minus line is y is greater than negative 2x. Okay, now the blue line. Okay, y is greater than 1/2 x minus 4. Okay, this tells when you take above the line. Is there above the line? All right. Okay, so look at that. Okay, otherwise the negative 4 right there, and then we move 1 over 2. Okay, okay. So the y is greater than negative 2x, and y is less than or equal to 1/2 x minus 4 is your inequality. Okay, it doesn't, unless it like asks you specifically for a certain color of y, it doesn't matter which one you return. So which one you have to return. So you can actually do almost the whole assignment already. Yeah, you can. You can probably take the first 8 problems. a few more than I was. Lots of that, but not too much. Alex or Harley, do you have any questions?
No.
Okay. Alex, last time I checked, you were done with the homework, but it's only from yesterday, so work on that one first before you do this one. But if you come across questions at any point, like send me an email or something, I can help you out.